Today we will talk about the impedance in chapter 10.5, series and parallel impedance. Impedance can be understood that as the register and the viewpoint of the frequency. So in time domain, we have three components here: the register R, and L, and C. And this is a R. This is L. This is C. So in the time domain, we can define this is voltage here. It's a VT, and the current is IT. And this is a VLT, ILT, and capacitor VCT, and current is ICT. And this can be represented in the pager. Now we define this is V omega, and current is IR omega. And define this is V L omega. This is IL omega. This is a VC omega, IC omega. The relationship between the current and voltage in each in the element, then VRT is R and IRT. But in the point of the pager, we can rewrite here. So VR omega is R I omega. In the case of inductor, the voltage and current relationship is L DTD ILT is VLT. Then they can be represented in the pager. It's very simple. J omega L IL omega is VL omega. And in the case of capacitor, we use very similar. VCT is ICT. In the case of the pager, we can rewrite J omega C, 1 over J omega C, ICT, IC, actually it's not T, IC omega is VC omega. So the impedance of GR is R, and impedance is GL is J omega L, and impedance C is 1 over J omega C. That is the impedance. Actually, this is very simple, but you need to remember this general expression of impedance in R and L and C. Okay. So when you use impedance instead of R and L and C, the impedance can be handled as if there is only a register in the time domain. So if impedance is connect here this way, and this in here, this is a G1 and G2. Actually, I don't know. The G1 is a resistor, or inductor, capacitor. I don't know what is that. We don't care about that. In the viewpoint of the frequency, this element is kind of something depending on the frequency. That's all. If the element is a register, then there are no affected by the frequency. Or it could be the register inductor, or it could be capacitor. I don't care about that. It can be represented in the frequency of the omega. So that can be rewrite here G equivalent. That is the same with G1 plus G2. I don't care about what is that. It could be resistor, capacitor, I don't care about that. So in the case of impedance is connected in series, then G EQ can be written here, the G1 plus G2 plus in this way. In the case of parallel, we have two impedance here, G1 and G2 and G2. Then this is the same way here. From the equivalent to GEQ is how this expressed in the parallel in the register. Remember, it's 1 over G1 plus 1 over G2 inverse. That is it. So if you express the admittance is inverse of the impedance. So admittance Y1 is 1 over G1 and Y2 is 1 over G2. Then YEQ is Y1 plus Y2. When you express the admittance in the impedance, then in the parallel case, admittance is the sum of each admittance. So we can prove this relation here. So first, we can do this. GEQ is G1 plus G2. I will show you here. So this is some circuit here. I don't know what is that, but there's some impedance. There's some impedance here. When we say this is a G1 and this is a G2, then we can define this is a V and this is current I. Then you can write here, this voltage is V1 and this voltage is V2. So we can redraw the circuit is one impedance here, GEQ. So this is a V and this is current. If this is same with this, that means V and current will be same. So how to make a V, this V and this V and this current is going to be the same? Okay, we need to do that. So here we define this current, this is I, and V is the same thing, same as V1 plus V2. Right, and here is V1 is G1I plus G2I. Therefore, this can be represented in this way, G1 plus G2 in I. Then we can rewrite here, V is GEQI. Therefore, if this V and I is the same with V and I, that means that variable is the same. So G equals same is G1 and G2. Therefore, the case of series case, we can adding you can add all impedance, then you can make an equivalent the impedance. How's in the parallel case? Parallel impedance. So we need to prove, I don't know what is K, what is circuit here, but anyway there are some impedance in parallel. We find here, this is a G1 and this is a G2, and we make this voltage is V1, this is a V2, and this current is I2, this current is I1. Then we make this is a V and this is I. So I want this circuit is one equivalent impedance. This is GEQ. Then this is a V and this is I. So I want to make a same voltage and the same current. And how to express the GEQ? That's the question. So here, or we can get it, the V source is the same way, the V1, this is a V2. And current, and because I1 and I2 is divided based on the I, so there is I1 plus I2. Then what is the V1? V1 is G1 I1, and V2 is G2 I2. Therefore, I1 is G1 V1 over G1, and I2 is V2 over G2. Therefore, I is I1 plus I2 will be V1 over G1 plus V2 over G2. But we know that the V1 and V2 and V is the same. Therefore, it can be written here is a V 1 over G1 plus 1 over G2. The big point over here, the V1, V is GEQI. Therefore, I is 1 over GEQ and V. And for same way, this V and this is same, and this current is the same here. To do that, this term should be same with this term. Therefore, 1 over GQ is the same as 1 over G1 plus 1 over G2. Therefore, GEQ is 1 over G1 plus 1 over G2 inverse. So this is the equivalent impedance when the impedance is connected in the parallel. So it looks like a register, so it can be very easy and simple. So when you transfer the circuit in the phasor, then the capacitor, inductor, resistor is not important. We just deal with only as impedance. Then you can apply the voltage division. And there are one source, voltage source here. And I don't know what is that, but it's an impedance. This is a G1. And there are another impedance here. This is a G2 here, and this is a V phasor. This is current I. Then we define this voltage is V1 and this voltage is V2. Then my question is, what is a V1 and V2? It's very simple because current is common. This current is common. Therefore, V1 is G1I and V2 is G2I. And we know that V equals same with V1 plus V2. Therefore, G1 plus G2 I. Therefore, I is V divided by G1 plus G2. We apply it here and here. If we got it, the V1 is G1 plus G2 V. Therefore, G1 plus G2 V. What's that? So voltage division. The V1 is divided by impedance of G1 and G2. So we can use the voltage division here. In the same way, we can do this. We can do the current division. So when the impedance is connected in series, each voltage or the voltage of each impedance is divided by the impedance. In a similar way, in the same manner, that when the impedance is connected in parallel, then current is divided here. So this current source, the one impedance and another impedance is connected in parallel. This is a G1, this is a G2. And this voltage is V1. Let's say this is V2, and this current is I1. The current is I2. And we define this is voltage V, and current is I. Because this is common, we know that the V is the same with V1 and V2. V and V1 and V2 is connected in parallel, so their variables are all the same. Then, where's the V? In the viewpoint of the resistance impedance 1, then V1 is G1 I1, and V2 is G2 I2. Therefore, I is same with I1 plus I2. There will be V1 divided by the G1 plus V2 divided by the G2. There will be V is common, it's 1 over G1 plus 1 over G2. This is what you have to do here. Therefore, oh no, this is long. I inverse the sequence here. No. Then we can say, because V1 is G1 I1, and V2 is G2 I2. So I is sum is I1 plus I2. So there will be V over G1 over G2. Because V1 is V and V2 is V, therefore the G1 ion is the same with the G2 I2. Therefore I1 is G2 over G1 and I2. Here we apply here. So I is G1, G2, I2 plus I2. So that will be G1 plus G2 I2. Therefore, I2 is G1 plus G2 G1 I. The same way, I1 is G1 plus G2 and G2 I. So this is a current division. We will exercise some example in the textbook. Example 10, 5, and 1. There are one voltage source here, and the resistor, and the capacitor, and inductor. So this is a Vs. This is 9 ohm. This is 1 millifarad and 10 millihelp. And the Vs is a sinusoidal input, so there is 100 cosine 100t is a volt. So if we solve this circuit in the time domain, it's very complicated. The second order differential equations is modeled to represent the circuit in the time domain. But in this case, we want to know the state in the sinusoidal, so we can use the phasor very simply. So what should we do? We can transfer this circuit is phasor. So I can do that. It's here. Transfer the circuit here. This is redraw. And this is one impedance. I don't know what is that. It would be resistor, capacitor, whatever it is. And one more impedance. And one more impedance here. And this is a Vs. This is resistor. So this is GR, this is GC, and this is GL. Yeah. Can be right here is omega is 100. Why? Source is 100. Therefore, we can rewrite the what is Vs? Magnitude is 10. This is cosine. So Vs can be 10 0 degree. Then what's GL? GL is J omega L. So J omega is 100 and L is 10 milli. Therefore, 10 and here. So where's that? 3. So there will be the J1. And what is that? There's 1 over J omega C. It's minus J omega is 100 and capacitance is 1 milli. So 1, 3. So there will be minus J 10. And GR is R. So there will be 9. So then we want to get the current here. It's IT. This problem. So I want to get the I. Then this can be written as the series connected impedance here. So the V, I mean this is Ohm's law. The V is IZ. Therefore, I is V over G. Then that is 100 in JODB. And where's G? G is because this is connected in serial. This series. So G is GR plus GC plus GL. So here we need to calculate what is GL plus GC plus GL. GR is 9, GC is minus J10, GL is plus J1. There will be 9 minus J9. So this is rectangular, the form. You can transfer that is a polar forms. So there is a, how you can calculate in the polar form. And we have been exercised previously. There's root 9 square and 9 square, and angle is arctangent. Actually, we can get the angle in the plane here. It's 9. This is minus 9 here. So that is that. So there's minus 45, minus 45 degree. So there is 9 to 2 minus 45 degree. So we can rewrite here 100 0 degree divided by 9 degree minus 45 degree. Therefore, there is 7.86 and 45 degree. So we can transfer the IT is in time domain. IT is magnitude is 7.86 and cosine omega is the same. So 100t and phase is plus 45 degree. And the unit is ampere. So this is a very simple problem, but to calculate some equations, you need to use calculator. There are another example. Here is example 10.9 and 2, 5 and 2. There are voltage source here, Vs, and one resistor and one inductor. So we define that is a alpha voltage T in 0.54 Henry, and this is 3 ohm. The question when Vs T is 7.28 cosine 40 plus 77 degree volt. Question is, what is V out? So it's very simple problems. We can redraw the page. So I can do that. Plus minus one impedance and one more impedance here. First we will write omega is 4 because this is 4, and Vs is magnitude is 7 to 5, and angle is 77 degree. This is a GR and GL. And GR is, what is GR? GR is 3, and GL is J omega L. J omega is 4. L is 0.054. That value is J2.16. Then what is a VO? VO is the voltage division is GR plus GL and GLVS. So you know that GL is J.2.16 and R is 3.J2.16 and V is 7.28 and 77 degree. So if you use calculator, it's a very simple problem. So I recommend you use calculator. But without that, you need to very complicated exercise in mathematics exercise. Anyway, you can do that. So when you take an exam, you can use the calculator. So in here, I will give you to get here the variables. The 3.J2.16 is 3 square plus 2.16 square, and that value is, maybe that value is 3. That is actually, that value is 3.7. So 3.73 plus J 3.7 2.16, there will be 3.7 and 36 degree. So we insert that variable here. So V out is 3.7, and there is 1.16 and 7.28, and pager is actually this is the 90 degree, so 90 degree plus 77 degree minus 36 degree. Then here, so in that case, the variable is maybe 4.25, and page is 167 minus 36. It'll be 4.25, 1 and 31 degree. So VOT is 4.25 cosine 4t plus 131 degree. Okay, but I will give you another example. If I mean in the problem, if you change in the if you change, I will give you another example. If you change that is this way, and copy and paste here. If you change your direction over here, instead of it that, you can change that is minus plus here, this way. Then how to solve it here? Maybe then if you transfer this socket here plus minus here the same way, this is GL, it is GR. Then you can change that is because we transferred the polarity of the source, so that is actually 7.28, 76 degrees, no, is minus, so that will be 7.28 and 76 minus or plus 108 degree. You can change the angle, phase angle of a source in this manner, and answer will be different. Anyway, so in textbook, the example is this. This is example in the textbook, and I will give you the simple problem. But when you solve the problem in this circuit, then if you change it like that, then you need to change the phase angle in this way. There are another example 10.5 and 4. So it looks more complicated like here. This capacitor and resistor. There's one more resistor, and there are one source here. This is a VS. This is 9 degree, and this is a capacitor C. And this is 4 ohms a resistor. We define there is a VO, and we define this is a VA. Then let's say the VS was 8.93 cosine 2t plus 54 degree, and V out was 3.83 cosine 2t plus 83 degree. The question is, what is a VA and what is a C? That's a question. So at first, I want to solve the V1 at first, or VA. And then we can redraw the circuit again in the phaser. So we redraw this circuit. This is one impedance. I don't know what's that, but I need GC. And this is one impedance, a GR. And there another impedance here. It's a G. It's a 4. Because this is register. This is 9. Because this is register. We define this is a VA. This is a VO. That is 3.83. 83 degree. And this is source here, and this is a VS that is 893, this is 54 degree, and here is omega is 2. Then first, I want to calculate the VA at first. VA, because of the KVL, we can calculate that the VS will be minus VA plus VO. So therefore, VA will be VO minus VS. VO was 3.83 degree minus 8.93 in 54 degree. If you use calculator, they will be transported in the rectangular form. This is 3.83 cosine degree plus J 3.83 sine 83 degree minus 8.3493 cosine 54 degree plus J 8.93 sine 54 degree. So that will be 0.247 plus J 3.8 minus 5.25 plus J 7.22. You need a calculator. So there will be minus 4.78 minus J 3.42. So we know that because minus and minus, there will be theta is here. There will be theta. So you can calculate it in calculator. So that value is 5.88 and the impedance in phase angle is minus 144 degree. So this can be rewritten here. So 580 plus 216 degree. So anyway, so because of VA is written here, so we can rewrite in time domain into VAT. Its magnitude is 5.88 cosine 2t, same omega, minus 144 degree. So we can calculate the voltage in this way. Another thing is we need to get the C, the voltage capacitance here. So to get that, we can you can use KCL here, because this is a node, so this current, you can define this current, and this current, and this current is the same, is 0. So now what is the current? We define this. Okay, this is IC, and you find this current is IA, and this current is IO. Then what is IC? I is because that voltage is VA, so VA over GC, and IA is VA over 9, because this is 9 ohm, and IO is VO divided by the 4. So we can rewrite here is GC is VA plus 9 VA plus 4 VO is 0. Therefore, because the GC is J omega C, 1 over J omega C, therefore J omega C VA plus 1 over 9 VA plus 1 over 4 VO is 0. Then VA, J omega C VA was C is 1 over VA 1 over 9 VA plus over 4 VO. So VA is here 588 minus 144. So can you write here 1588 minus 144, and 1 over 9 is 588 minus 144, and plus 1 over 4. The VO is 3.83, and pager was 83 degree. So you can use calculator. Then that variable is simple, 0.12 90 degree. So there is a J12. So from here, the C is 0.12 and omega. The omega was 2, so there is 0.06. Therefore, C is 0.06 the farad. So as you see, when you solve the logic circuit in the pager, so the concept is very simple. You can deal with all element like resistor, capacitor, inductor. You can deal with their impedance. So it's not important what is the R or LC. You can deal with the impedance, and you can deal with that as like a resistor in the time domain. But the calculation is a little bit complicated, because the variable is a complex number. So only difficult thing is calculation, because there is a complex number. But the approach to solve the logic circuit is very simple, because we can deal with all of the impedance element is like a resistor in the time domain. Next, we can deal with that is the mesh and the node equation. And to solve And as we solve electric circuit in the time domain, the mesh and node equation is very useful, the approach to analysis the electric circuit. We can apply the mesh and node equation in the frequency domain, especially in the pager. So I will give you an example here. The example here. Let me put that. I will give you explain a little bit. And there are some element here. So, and there one the reference and define the node voltage is V1 and node voltage is V2. This is node voltage in the pager. Then element voltage is VA is a V1 minus V2. Okay, so if this is a G, then the current of this here, current is I, then I is V1 minus V2 divided by the G. This is a node equation, the component analysis. In the same way, there are one element here. Sorry. There are one element here. This is G. But there are two meshes. This is mesh 1, I1, and this is mesh 2 and I2. Then this current is IG is I1 minus I2. Oh, not G2. This is I2. This is I2. Therefore, the voltage V is GI. Therefore, the G is I1 minus I2. So we can apply the pager in the mesh voltage or mesh current and the node voltage concepts. So I will give you an example. That will be a little bit complicated. So the size of these diagrams. Here. As an example 10.6 and 1. So we're going to determine the voltage VAT using the node equation. So look at this a little bit simple. There are one source here and resistor and inductor and capacitor and current source, inductor, the dependent voltage source here. It looks like that. It looks like a little complicated, but it's a very simple problem. So that value is 8 ohm. This is a 36 millihenry in 0.25 millifarad, and voltage is 20 cosine 250 t, and we define that is a VA. Then 1.2 cosine 250 t plus 45 degree, that is 80 millihenry, and this is 4 VAT. The question is, what is VA? That is my question. It was a little complicated, but we can solve very simple using the pager. So it's very fun. Right, and redraw this circle. Okay, here, but we will change the variable is a pager. You know that we write this is a pager. Then what's that? The pager, I mean omega, we need to write omega is 250, and that is a 20 and 0 degree, right? This is 8 ohm, so there is a 8 because it's a resistor. And this is a 35 millihenry. Therefore, the impedance GL is J omega L. Now J omega is 250, and L is 36 in minus 3. That value is J. We need to calculate here. The calculator is J9. It's very simple. J9. And how about that? How about that? There will be 1 over J omega C. They're the same with minus J 1 over omega C. Minus J 1 omega is 250, and capacitance is 0.25 and 10 minus 3. So that value is minus J16. You need to calculate here. So that is minus J16. Also, that value is 1.2, and pager is 45 degree. And that is J omega L, because the inductance J250 and 80 minus 3. So that will be J20. This is J20. Then we check 4 VA pager. We replace, that is a VA. Number is very simple, and very simple. So we need to make a node equation here. So how to make a node? This is a reference node. We can rewrite. This is one node. This is node, and we make this is node, but we can make a one impedance A4 J9. Okay. So we define this current is I1, and this current is I2, and this current is I3. So we can get the I1, and I1 is voltage difference over here, from here to here. This is VA, this is their values. So minus VA is divided by the impedance A plus J9. And what is I2? I2 is impedance is, when the voltage is VA, the impedance is minus J16. And what is I3? I3 is here. The voltage is, because this is VA minus that voltage is 4 VA, and impedance is J20. This is impedance. So based on this this node, we can make a KCL. I write to make a I1. I2 is going out from the node, minus I2, and this current is going into the here, plus 1.245 degree, and this I3 is going out here, minus I3 is 0. So what should we do? Next, apply, that is here, that is here, and that is here. So we rewrite this equation is 920 minus VA plus VAJ 16, because minus minus, and plus 1.245 degree minus J20 VA minus 4 VA. There is a 3 VA and plus, so plus 3 VA is 0. We have one equation. We have one equation, and we have only one variable, a non-variable VA. So we make a simple equation is minus 1 over A point J9, minus and plus 1 over J16 and plus 3 over J20 VA will be minus 20 0 A plus 9 and minus 1.245 degree. So we can calculate using the calculator that variable and the depth variable. So to do that is 0.0552 plus J 0.1514 VA is the same with 1.952 minus J 0.3929. So we can calculate the VA is 12.4 and minus 81.2 degree. Therefore, VAT is 20.4 cosine omega is 250t minus 81.2 degree. So this is a simple, but the circuit looks like very complicated. If you solve this circuit in time domain, it's very complicated. But if you use a pager, then you can calculate the V8 very simply like that. But only the typical thing is calculating the complex number. But you need to use the calculator. But if you use that, then the problem is not difficult anymore. This is another example of the node equations. The example 10.6 and 3. So we use node equation. So the circuit here is a VS, and there are one resistor and their capacitor and one resistor and one dependent source and one inductor and their resistor here. Yes. Okay, this is a VS. This is 10 ohm. This is 10 millifarad. This is 10 ohm. Then this is we define this is IT. Then the voltage is 10 IT in 500 millihenry. This is 9 ohm. It looks complicated, but uh, we need to calculate the IT. That is a question. So to solve this, we need to redraw this circuit again. Okay, here. So we draw the circuit again. Okay, because Vs, I mean the problem, the Vs was with t is 10 cosine 10t. This is a given. Therefore, at first we write omega what is that? Is 10. And that is Vs is 10 0. Then this is 10 ohms. That variable is 10. This is 10 millifarad. So capacity impedance is 1 of j omega c. So minus j 1 over omega c. So minus j, omega is 10, and capacitance is 0.01. So that value is minus j10. That is minus j10, and that value is 10. Then that value is j omega l is j omega is 10 and is 0.5. Therefore, it's j5. This is j5, and this is a 5. And you define this is pager a current, then there will be 10I. So we make this as a reference node here. Then our constant is current. So at first I make a simplify this, the parallel impedance. So there is a parallel connection here. So we can redraw that is a, we can redraw here. We can redraw one impedance like that. There is a parallel minus j10 and 10. So minus j10 parallel 10 is the same rate 1 over minus j10 plus 1 over 10 inverse. So what's that? That is 1 over 10 j plus 1 over 10 inverse. So that is a 10 1 plus j inverse. So 1 over j 10 then it can be right here 1 plus j 1 minus j 10 1 minus j. So there will be 2 10 1 minus j. So there will be 5 minus j 5. So that impedance is 5 minus j 5. Anyway, and the remake was one impedance here. So that is changes only one impedance, because this is currently in series. So that is 5 plus j 5. So circuit looks more simple. And you define that is a V1. So I, its current is I. This I is the current flowing here. So that will be that is 10 0 minus V1 divided by impedance is 10. Then we define this is a v2, then 10i is v2 minus v1. From here, the v2 equal to 10i plus v1. Then I know that you can use a node equation. This current I is the sum of this current and this current. And this current is, we define this is I1, this is I2. Then I1 is V1 divided by 5 minus J5. And I2 is V2 divided by 5 plus J5. Then what should we do? Then we summarize this relationship, it's current and voltage here. So we can make equations. I is define this is a G1, and you define this is a G2. Then I is I1 plus I2 is I1 is V1 divided by G1 and plus I2 is V2 divided by G2. Then G2 is here. Therefore, I is 1 over G1 V1 plus G2 1 over G2 and V1 plus 10 G2I. And we can define this is a Vs, then I V1 plus 10Is is a Vs because this is V1 and 10I, that variable is here, is Vs. So we summarize this is a more simple, then we make a matrix here. No, I will drive more simple. From here, we multiply the G1 and G2. So G1, G2I equal G2V1 plus G1V1 plus 10 G1I. So from here, we rewrite here is G1 plus G2V1 plus G1 10 minus G2I is 0. Then here 1 V1 plus 10, I'm sorry, this I is this I, 10I is Vs. Therefore we rewrite in the matrix time here. So 1, 10, G1 plus G2 and G1 10 minus G2 V1 I1 B Vs 0. So using the matrix calculation, we can get it the V1 and I1 is 2.84 and 0.8 minus J.4. Therefore, I, actually this is I is 0.8944 is minus 26.63. For IT is cosine omega is 10t minus 26c3. That's your solution. So you need to calculate the phase current and phasor using the node equation, the mesh equation as you want. I mean, when you learn in the last class, in the last semester in the circuit theory first, you deal with you use mesh method and mesh voltage mesh current. Mesh current method and node voltage method. You can apply this method when you use the phasor. This is very simple.